In this video, we're going to talk about decimals, and specifically what decimals actually mean, what kind of place value different points behind a decimal point actually have. So for example, if we have two scenarios, one child has this coin right here, which we know is a $1 coin. We would just write that as a dollar sign and a 1 behind it. Right? That's a dollar. It's a one whole dollar. But what happens if that child, instead of having just $1, also has 10 cents as well? So he has both a dollar and 10 cents. Well, now we write the dollar sign and 1. But we have a decimal point and then a 1 behind it. Now this means that this here would be your 10 cents, right? Your 10 cents. And the 10 cents are worth less than a whole. In this case, less than a whole dollar. So anything behind the decimal point is basically worth less than one whole. That's what we need to know about decimal points. The decimal point is anything behind the decimal point. So in this case, we've got our decimal point right here. That's our decimal point. Anything behind it is worth less than a whole. So even though this number right here, 2.222, all these numbers are the same, we only have 2's, but each of these 2's is worth a different amount. So the one in front of the decimal point, which in this case is a number 2, which I highlighted in red, this is actually going to be in the ones column. So the ones are going to be worth the most because it's one whole. We've got two wholes, right? So that means these are complete numbers, whereas anything behind, the first one in the green, for example, right here, the 2 in the green, is the 10th column, and that's going to be less than one whole. So it's going to be smaller than one whole. In this case, that could be the 10 cents, for example. Now, the 2 behind, so the one in blue, is worth even less. We call that the 100th column. So 100th column. So the 100th is worth less than the 10th. So for example, if we had 10 cents right here, these are 2 10 cents, that's 20 cents, then the number behind it would be your 1 cent, right? So in this case, we have 2 cents and 22 cents. So 20 coming from the 10th column, and the 2, these are just your normal cents. So the normal cents are worth less than even your 10 cents beforehand. And then the next column we call the 1000th column. 1000th column. This is going to be worth even less. So we have the biggest decimal, value in terms of decimals is the one here in green, which is called your 10th. Then comes the 100th, and then comes the 1000th. So as we go to the right, basically they become worth less and less and less. And you need to realize that the way we name these is just we always add a th to its normal name. So 10th, 100th, and 1000th. So what happens if we have two numbers? We have these two numbers, 1.211 and 1.199. If we had to compare them to figure out which one's bigger, what would we do? Alright, so first of all, we need to realize that in the ones column, which would be these ones right here, they both have the same amount of ones. So this here is the same. So if the ones are the same, we move on to the next column, which will be the 10th column. Right, so remember that's 10th column. Now here, the number on top has 2 tenths, whereas the number on bottom only has 1 tenth. So we are going to know that this number is going to be bigger because 10th is worth more than all the numbers behind it than the number below it. So even though the number below it now has a 9 in the 100th column and a 9 in the 1000th column, but because the first number had the bigger 10th column, in the 10th column, this is going to be the biggest number. So 1.211 is more than 1.199, right? So you look at the 10th first, and in this case, if the 10th is bigger, then it doesn't matter what happens in the 100th and in the 1000th column, right? So that's how we compare decimals. In this video, I'm going to quickly talk about how we can round off decimals. And the reason why we often have to round off decimals is because many times the number behind the decimal places might be too many. There might be too many decimal places. We want to shorten the number. So for example, in this case, we have a dollar and 256. So that means that 2 here stands for 10 cents. So we have 20 cents. The 5 here is the cent column. So we have 5 cents. So that's $1.25. Now the question would be, what does this number represent? And the money, we don't have anything in the thousands column. So this number we have to remove because it just doesn't exist, right? We can't have 125.6 cents or something like that. It just doesn't work. We can't give you that many money. So we have to remove that number, and then we have to just round it out, round it up or down depending on what we have to do. And there's two rules. So either if the number, so we're trying to get to nearest cent, right? We're trying to get to nearest cent, and if the number behind that is equal to or more than 5, we round up. And if the number is less than 5, we round down. But what we mean by we round down is the number just stays the same, right? So rounding down just means more or less stays the same. So in this case, remember our number is 1.256, and when you get to nearest cent, so this would be this column right here. So what is the number behind the nearest cent column? Again, that's number 6. So in this case, the number 6 is equal to or more than 5. So that means that we have to round, we have to go one up, right? We have to round up. And that means that the number in front of that number, which is the number 5, is one higher. So what that means is it becomes $1.26, right? Now we have rounded up. So it used to be $1.25 and 6, but then we have rounded up to get to $1.26. I'll show you a few more examples. So for example, here we have a number 2.5456, and we want to get it to nearest tenth. So remember the tenth was the first number after decimal. This is your 10th column. So to figure out what we have to do, we have to look at the number behind the 10th column, which in this case would be the 4 right here. So the 4. Now it says if the number is less than 5, we round down. And remember, all that means, rounding down, means the number stays the same. So what it means is it's going to be 2.5. This 5 is our 10th column, and because we round it down, because the number 4 behind it is smaller than 5, the number just stays the same. In this case, the number was 5. Alright, so how about 3.123? To nearest whole number. So remember, the whole number was the number before the decimal point. This is our whole number. So we have to get to the nearest whole number. So what's behind the nearest whole number? Well, in this case, we have a 1. So the same thing. If we look at definition, if it's less than 5, we round down, which means the number stays the same. So 3.123 just becomes 3, because this is our nearest whole number, rounded down, because we haven't gone up. Rounding down means the number stays the same, but the rest of the decimals are gone. That's what the idea of rounding down means. Alright, so how about 14236 to nearest thousandth? So in this case, the thousand column would be, this is the 10th, 100th, and this is the thousand column. So the number behind the thousand column would be a 3. Same idea. So we want to round it to nearest thousand, so it's going to be 0.14, and number behind the thousand is a 3, so that means it stays the same. It stays a 2, because it has to be 5 or bigger for it to go up by 1, right? So now we have removed these decimals in the end, and we've shortened the number by rounding it down to nearest thousandth.